Shauna Pinkerton. I teach forensics and honors chemistry and scientific research and design here at Snyder High School. I am also a part of the Robotics ACE program after school. We meet 2 days a week, Mondays and Tuesdays from 4 to 5. And my guys that I'm fixing to introduce here in a moment have been a part of this from the beginning, and they have done great things with the robotics, even played pranks on me. It was a lovely morning when I came in and robots started going all over my room. We also have a very special guest. This is 3D Douglas. He is our 3D printer that we received here at Snyder High School. We opened him up this year, and we have really come a long ways understanding how the 3D printer works, and both the gentlemen that I'm going to introduce here in a moment will be able to tell you a lot more about that. We're able to print things all the way with their hinges and everything, and so the 3D printer does everything all on one place, and so it builds it up with ABS filament, and they will be talking about that here in a few moments. The ACE program has really helped us out with the robotics, and the gentlemen are very excited because they're fixing to get 3 new kits to build their robot in any shape they would like, and using different sensors to allow that robot to function, whether it be the remote control or by light or by sound. So they're very excited about that. The MakerBot 3D printer runs off of a MakerBot program. However, we have just did some applications with Google SketchUp, and so we are ready for the next phase of printing our own things that we have designed, and Google SketchUp has provided a very easy way to make that happen. And so the guys are very excited to get to design their own thing and have a tangible product when they're done to associate with their drawings on the CAD drawing system. Okay, so my gentlemen that have been helping me out all year, and they know everything about 3D Douglas, and they are seniors, so there will be severe tutorials going on prior to them graduating. Are some really great kids that do problem solving. Some of them want to be engineers, but I'm going to introduce them. Jonathan Lewis and Chris Benavides and Mr. Brady Dowds, and they are our 3D gurus and also our robotics gurus, and so I really have enjoyed having them around. I have learned a ton. If you want to know anything about soldering, these guys can do it, and so I've really enjoyed having them after school, and we've had a lot of fun together. So I will leave it to them and let them describe to you the stuff that they've been doing.
So right now we have these minions printing for Valentine's Day. They're holding a little heart. The printer's running right now, and it's running from the back. There's some filament right here, and what happens is this middle string, it's on the back, and it runs straight up through this guide tube, straight into this block right here that's moving around. Heats it up to 230 degrees Celsius, which is 430 degrees Fahrenheit, somewhere around there, which, I mean, ridiculously hot. What happens is it builds a base first that's later broken off from the actual product of whatever we've built, whether it's a minion, a little Pac-Man guy, or chain links or anything like that. Oh yeah. The heart box was one of our first big projects, if you will, and the printer will actually print hinges off of the guide or the filament. I mean. And it's completely workable, both sides open, swivels both ways. Pretty neat.
To print stuff, it's a website made by MakerBot, and really it has thousands and thousands of things on it. And you can search for pretty much anything you want. You have to make sure it has to be a CDL class file, and it just transfers the file from this computer onto the printer, and it can pretty much print anything you can find on here.
I mean, right here you can see Chris looking up.
This is just you can look at random things, and right here you can print a fruit bowl. It looks like it's made out of pencils. That's how random stuff is. And really, you can find tons of stuff. Here's a horseshoe. Let's see what else we can find. See, here's a tray that's labeled with numbers in the sections. I mean, it's pretty much endless what you can find on this website. And there is a program where you can actually make this stuff, but we haven't got that far yet.
Which is what Miss Pinkerton has previously, what was it called? Google Sketch? Google Sketch, I think is what it was. And hopefully here pretty soon we're going to be learning how to do that so we can make our own stuff as the menus are running right now. We have a girl in our scientific research and design class named Maddie Forrester, and she is printing a glucose model because she's doing her project in scientific research and design is over diabetes. So she's going to come in here and look up just on Thinking Universe, like we have already said that you can look up just about everything. Just look up a glucose model, and then the glucose model will just get sent from the computer straight to the printer, and it'll run through all this right here, and it preheats itself so that all this filament right here will melt down because it goes from, I don't know, how big would you say that filament is, like all the way 1/8 of an inch to like 1/32 of an inch. Like it melts down. And each individual one of these right here, this just alone from the bottom to the first layer right here is probably like 1,000 lines of filament.
You can see how many lines this is doing.
Oh, it's another thing. We can actually go through a menu right here and look at the lines that this build is on. This build is on line 39,196.
It's constant. Here, I found a glucose molecule.
Oh, look, there you go. There's Maddie's glucose molecule.
So you can actually like see what the molecule looks like in your body.
So basically, after high school, I'm gonna go to South Plains and I'm gonna get my associates in music, just because music has been a big part of my life. And then after I get all my basics at South Plains, I'm gonna transfer to tech and then pursue my master's in electrical engineering. And overall, this has helped me a lot just by understanding how technology works with, or how some technology is compatible with other technology. Chris and I have pretty much broken this thing down 100% up at the top. And we can take every single thing apart of it, lay it out, and we know exactly what goes where. Because whenever we first got it, like a little piece of the filament got melted inside of it.
It's like years.
So we had to take the whole thing apart. So we know how to clean this, we know how to run it, we know every setting that it's running on, we know everything except for like the actual makings and programming of it. But overall physical appearance and how you can see it run and everything like that, we know how that works.
After high school, I plan to go to Texas Tech and be a mechanical engineer. Really, this just opened up my eyes. Like, this didn't come from anywhere. Someone made this, and it catches people's eyes. I just think that's amazing, and it like helps me. Like one day, I want to make something that's like, wow, that's amazing. It really catches people's attention. And really, this has opened my mind, saying like, someone did this, and someone's proud to say that they made this. So one day, I hope to make something of my own like this. Okay, good.
Okay, so basically, this right here is a full finished product of all of this stuff put together. We run straight from a circuit board. This one's just a smaller one as opposed to this one. This one's just bigger. We run the wires out of the circuit board onto these, which are just solderless breadboards, where we don't actually have to fully solder things. We just hook up a power cord to hook up a power cord to the edge right here, and we can line all this stuff up onto it, which is like, I mean, this is just a positive and negative power cord right here, and we have ceramic capacitors, photocells, and what the photocell does is, on some makings of this, we can set a photocell on the top of the breadboard in a certain pre-positioned place, and we can set our phone lights or a flashlight or an LED light or anything like that to it, and this robot will actually follow the light. So when the printing's all done, this is run on, it's called the X-axis. The platform runs straight down.
Oh, you're doing things.
The platform runs straight down, and whenever it first prints, it prints this little very thin base onto it, and you just snap it off whenever it's done. And then it just makes a little leaf. And we just, since we happen to build these smaller characters, it made it each individual person has their own base. But whenever we made the heart box, it had a giant base all the way around here, and then we just snapped it off, and it holds it so that while it's printing, it's not moving around all over the place. Whenever you have something as round as this is. And then just got one more. And then there's all 4 of them, and now we're ready to print something else if we need to.